All right, in this screencast, we're going to be looking at how to complete that atomic structure worksheet. So in order to understand the atomic structure worksheet, we have to understand the periodic table. So let's do a quick introduction. On the periodic table, this is the symbol. Right here, the letter or two letters. Below it, this is going to be the atomic mass, or how much mass the atom, a single atom is. And this right here, this number right here is going to be the atomic number, or which is equal to the number of protons. Now, in an atom, there are protons and neutrons in the nucleus. Both a proton and a neutron have a mass of 1 atomic mass unit. This is going to be important for understanding how to find the number of neutrons. So remember that both protons and neutrons have a mass of 1 atomic mass unit. Electrons are so small that their mass is negligible, and we're not going to take it into consideration. So if we look at carbon, carbon right here has a symbol of C, and its atomic number is 6. So that means that it's going to have 6 protons in the nucleus. However, its mass is 12. It has a mass of 12 atomic mass units. So if there's 12 atomic mass units, and 6 of those mass units are protons, then the other 6 are going to have to be neutrons. So let's look at what that looks like down here on the worksheet. Carbon has an atomic number of 6, an atomic mass of 12, and so our number of protons is going to be equal to our atomic number, and our number of neutrons is going to be the atomic mass minus the number of protons, right here. Our number of electrons in a neutral atom is going to be 0. That's because you're going to have the same number of electrons, negatively charged particles, as you do protons, the positively charged subatomic units or particles. So if you have equal number of positive and negative particles, then you're going to have an electrically neutral atom. So let's look at sulfur here. Sulfur has a symbol of S. Its atomic number is 16, and that means that it's going to have 16 protons in the nucleus, and its atomic mass is 32 atomic mass units. So 32 atomic mass units minus the 16 mass units of the protons, well, that's going to give us 16 atomic mass units left over for neutrons. Let's look at how that looks here. Sulfur has 16 protons, or its atomic number is 16. Its atomic mass is 32. So the atomic mass minus 16, 32 minus 16 is 16. And because it's electrically neutral, 0 here is going to have 16 electrons, same number of protons and electrons. Now when we look here at the valence shell, we can use the periodic table to give us all of this information here. So let's go back up to our periodic table. The number of electrons in the valence shell, which is the outermost shell, is going to be right here, 1, 2, 3, 4, 5, 6. It's in the 6th column, so therefore it has 6 electrons in its valence shell, or its outermost shell. So chlorine will have 7 electrons in its outer shell, and silicon will have 4 electrons in its outer shell. But we're talking about sulfur right now. So let's go down here, and we put 6 valence electrons. Now we're going to look at what it means to gain or lose and share. Since sulfur has 6 valence electrons, let's look at this here. It has 1, 2, 3, 4, 5, 6 valence electrons. In order for it to have a full valence shell, in most cases meaning 8 electrons in its valence shell, it would have to gain 2. So I put these little marks here for 2. So it could either gain 2 or lose 1, 2, 3, 4, 5, 6. It would be a lot easier to gain 2 to have a complete valence shell, or to be most stable with 8 electrons in the valence shell. Remember that atoms are most stable with 8 electrons in their valence shell. So if we look up here, we would have to gain 2 or lose 6. So what we're going to do is it's going to end up sharing 2 electrons in some sort of bond. Let's look at what that looks like on our periodic table. So here, since it's in the 6th row, it means it has 6 valence electrons. But do you notice we have a 2 here? The 2 means this is how many it would have to gain. 1, 2 electrons to have a full valence shell. Or it would have to lose 1, 2, 3, 4, 5, 6 to have a full valence shell. So it's more likely going to lose 2. So here it's going to lose 2. Let's look at magnesium. Magnesium is, let's go back up. Magnesium is here. It has an atomic number of 12 and an atomic mass of 24. We're going to round down because it's 24.3. And so if it's 24 minus 12, it's going to give us 12. It's going to give us 12 neutrons. And so let's look at what we have here. Magnesium, atomic number 12, atomic mass 24, number of protons 12, number of neutrons 12. And because it's a neutral atom, it's going to have 12 electrons because it's going to have the same number of positives and negatives. And so we'll have 0 here. Number of electrons in its valence shell is going to be 2. 1, 2. 2 electrons in its valence shell. Let's look at what that looks like when we've drawn it out. So if this is magnesium, we've got 20 electrons altogether, but it ends up that 2 of those are on this valence shell. So 1, 2 electrons. Now we would have to, in order to have a full valence shell, remember we want 8. So we could either gain 1, 2, 3, 4, 5, 6. These are just scribbles there to make a point. These aren't part of the atom. Or it could lose 2 and have this become the full valence shell. And remember, atoms are most stable with a full valence shell. So it's probably going to share 2 of its electrons. So we have magnesium, 2 valence electrons. It would have to gain 6 or just lose 2. So it's going to end up sharing 2 in a bond with another atom at some point. It gets a little bit trickier as we look at calcium or any of the ions. Remember that an ion is an atom that has gained or lost electrons. Only electrons, never protons. If you change the number of protons, you're changing the identity of the atom. So here we're looking at atoms that have a changed or an altered number of electrons. Let's look at calcium on our periodic table. Calcium is here. Calcium's atomic number is 20, atomic mass is 40, so 40 minus 20 is going to give us 20 neutrons. And this down here is saying that it is a calcium plus 2. So at this point, it will have to have given up 2 negative charges. Let's look at what that looks like here. So if this is calcium, so calcium, a regular neutral calcium ion or atom would have all 20 of these electrons. However, we're saying that it's calcium plus 2 because it has already gotten rid of those 2 electrons to have a full valence shell. So it's gotten rid of one negative charge, two negative charges. So now it is a +2 ion because it has gotten rid of two negative charges to have a full valence shell. So its valence shell is 8. Let's look at what that looks like here. So we have all of this information here, except that when we get to the number of electrons, if it was a neutral atom, it would have 20 protons and 20 electrons, but it got rid of 2 electrons, or 2 negative charges, so it is now a +2 ion. And the valence electrons is going to be 8. The rest of this is going to be blank because it doesn't matter now. So here, if we look at this here, calcium, the calcium atom was going to be, would have to lose 2 electrons to be stable. So the calcium ion lost 2 electrons, 1, 2, and now it has a full valence shell. Try the rest, finish this up, and come in and ask questions if you have any questions.